Hey everybody, Dr. A here, and in this video we're going to be providing some background information on allowable stress. So what is allowable stress? Well, this is based on a design philosophy called Allowable Stress Design, which we sometimes abbreviate ASD. Now, this is a design philosophy that engineers use to size members or determine required strengths of materials that those members are made of. And it's based on what we call a factor of safety, which we sometimes abbreviate FS. So what we do is we relate a factor of safety to a failure situation and an allowable situation, okay? Now, in this version of the factor of safety relationship, I say Fs is equal to a failure force divided by an allowable force. Now, we could express this in terms of normal stress by saying that the factor of safety against failure is a failure normal stress divided by an allowable normal stress. And then similarly, if we're dealing with shear stress, we can say the factor of safety against shear failure is given as the failure shear stress divided by an allowable shear stress. So what you can do is think of factor of safety as like a safety cushion or a safety net. Okay, so let's say that we are designing a mechanical component of a machine, okay? And let's say that that mechanical component of a machine is going to have to withstand a force of, let's say, 25 kips, okay? Now, if you design or size that component to handle exactly 25 kips, and you expect there to be 25 kips on that component, then what's your factor of safety? Well, it would just be 1, which is not very safe. That means that when that component is subject to the 25 kips you expect, if it's only strong enough to support 25 kips, then you're on the precipice of failure. So as engineers, we need to build in safety factors so we don't get right up against failure. We don't have something that's always about to fail. So for different components or different materials, we design them with factors of safety bigger than 1. Now, depending on what the situation is, you might be designing for a factor of safety of 1.5. or 2.0 or 3.0. It just depends on the particular situation, what you're designing it for, and why you're designing it, okay? So again, nevertheless, we're relating a failure situation to an allowable situation, okay? And that's what we say in this sentence here. To size members or their connections based on stress, we take the allowable normal stress as a normal force divided by an area that it's spread out over. Or if you're dealing with shear stress, you say allowable shear stress is shear force divided by an area that's being sliced, or a shear area. And so you build in this F over A into the denominator of this factor of safety relationship, and then before you know it, you have related a factor of safety, a failure stress, with F over A. Similarly, you put this V over A in the denominator of tau allow, okay, and then you'll have a factor of safety equaling a shearing stress failure divided by V over A. And so that's how we can relate a cross-section area into factor of safety and then size a member, okay? And so we can say solve for A there, all right? So that's our quick background information on allowable stress. We're going to have some examples where we illustrate this numerically. So if you found this helpful, please hit like and subscribe, and check out the examples we're about to have after this video on allowable stress calculations. Thanks for watching.